Okay, let's take a look. Here we go. What do we do? Let me pull up the calculator. Somewhere. Oops. Okay, so where is? There's our data. Okay, talk me through this, please. What do we do if I want to stat? Edit. And then I've got a bunch of data in there, but it's the wrong data. So how do I get rid of it? What? L2. Clear. Enter. Right? L1. Clear. Enter. Okay, good. And then put the data in, right? Okay.
How come I can't see
You can't see what?
I can't see anything.
Yeah, that's what mine did.
Okay, probably plot 1's probably not highlighted. Yeah. We'll get there. Hang on one second.
Yeah, there we go. There you go.
Okay, so no, hey, with me, please. Hang on. Everybody, face front. Thanks. Okay, so I got all the X's in first, right? Hit the right arrow over to the Y column and put in the corresponding Y values. Now remember, it's really important that obviously you want to get the right numbers in there, but you also have to make sure that they match up with the appropriate ordered pairs. You know, these come in pairs. There's an X and a Y value that go together. Okay, so okay, and then as a quick check, we always want to make sure that we've got the same number of X entries as Y entries. That's a pretty good bet if we do that we've got them in there correctly. No guarantee, but it's pretty likely. So I've got my data in. Now, how do I generate a scatter plot? That's the first thing I want you to do. Not trace. What do? I want to generate a scatter plot. Where do I have to go? I go Y equals, and I want to get rid of that, right? I want to get rid of that equation. That's old news. So I'm going to clear that out of there. And now everything's cleared and turned off. What do I have to turn on if I want to see scatter plot? Plot 1. So I have to go up to plot 1 and highlight it. So now it's highlighted. Do you remember? Now it'll graph it now. But if I just hit graph, it's going to give me whatever the X and Y window, however the window was set up previously. That's what I'm stuck with if I just hit graph. If I hit zoom standard, that's going to go from -10 to 10 on the x-axis and -10 to 10 on the y-axis, and that's probably not a good fit for my data. How do I get the calculator to fit the window to my data? Yeah, how do I do that? Remember, there's a trick. It'll do it for me automatically. Based on the stuff that I put into the stat editor in L1 and L2, it'll size the window to fit that. What was the trick, though? It's on the zoom menu. Yeah, when we want to size the window automatically, we always do zoom. But which one was it? Zoom 9. Good. Zoom 9 is zoom stat. There it is. Okay, so there's our scatter plot. Okay, so check. We did that one. Now find the equation of the best fit line. How do I do that? Not zoom. Zoom is for sizing the window. Now I got to go back and do the regression stuff. What screen is that probably on? Stat, right? Statistics. We're doing some statistics stuff here. So we'll go stat screen, calc menu. So we hit the right arrow to get to the calc menu, and then 4. You'll get used to that. Stat right 4, stat calc 4. We'll do that a lot. Okay, now here's everybody should have this screen. Linear regression, AX plus B is the form we're using. Now we're going to just verify a couple things. X list is L1, yeah, we know that's true. We did that. Y list is L2. We always do that. We always put the X's in L1 and the Y's in L2. Frequency list, you can just forget that one. But what about the store regression equation? It's in a way that's optional, but if we look ahead to what we're going to do in step 3, it's really not. We want to predict the value of y when x is 12. So we're going to want to use the model that we're generating. And the best way to use the model is to actually make a graph of it, so we can just play with the graph on the calculator to get our answers. So what do we want to do with that store regression equation option there? Yeah, we're turning it on, but how do we do that? We have to. This is where we're going to store the regression equation as a line, right? As y. Y is going to equal ax plus b. We want to store it. If we go back to the y menu, notice that all the y's, we can graph a whole bunch of things at the same time if we want to. We're not going to right now. But later on in the class, we'll graph multiple things at once on purpose and try to find intersections, for example. That's why these are all, they're all lettered. We can do y1, y2, y3, all the way down to, I don't know, y10 or 12. There's a lot of them we can put on there at once. But we need to capture one of these for our regression equation. So why not just use y1? So we'll go back to stat, calc, 4. And for the regression equation, we want to put a y1 right there, right? So how do we do that, remember? It's a y variable we're putting there, right? So variables, right there. Variables button. What kind of variable? Y variable. We always want a function. We're never going to use parametric or polar or any of that stuff. So we'll just use function, and then we'll choose y1. And so it inserts the y1 there like we asked it to. And now I can go down to calculate and hit enter, and we got it, right? Okay. Now, did we talk about the R squared stuff on Friday?
No, we didn't.
We did, okay. How many people, is anybody missing R squared or R on there? You are missing those, okay. We'll get to that in just a second. The A and the B are all we need for this case up here. Find the equation of the best fit line. Well, it's in the form y equals ax plus b. There's A, and there's B, right? Okay. So then the line is just going to look like y equals, now we're going to have to round this. In Moodle, what I'll have you do is just round all the decimals to, I can't remember what I said, 2 or 3 places, something like that. Say we're rounding them to 3 places. I get negative 1.110x plus b is 2.271. I rounded 3 places. There's the regression equation. Whoops. Okay. Predict the value of y when x equals 12. Okay, now here's where we can use the graph. We can go back to y equals, and now notice that our equation is in there, right? So if I hit graph, I actually get the equation of the line superimposed over the data. That's kind of nice, so you can see, that's what the best fit line looked like for that particular data. But we're pretty much done with the data now. The data was useful to us. It was nice to see the scatter plot. But really, the main reason that we ever made that scatter plot is so that we were able to hit zoom 9 and get the screen sized up around our data. Okay? We don't ever really have to see the scatter plot, but it's handy for us to have it up there initially so we can hit zoom 9. If I didn't have the scatter plot up there and I hit zoom 9, it wouldn't do anything because it only works for scatter plots. Let's go back now and turn off that plot. We don't need it anymore. All we really want now is the linear model, the regression line. So I'm going to go up and unhighlight plot, hit graph, and there's my line. Now this is useful. I can do stuff with this like if I want to know the value of y when x equals 2. Okay, let's just check something out here. If I actually let's do when x, let's do that. When x equals 2, what's the value of y? So we'll go second calc. Whenever I want to ask a question about a graph, I always go to the calc menu, second calc, and then I want the first option, which is value. It's going to ask me for the x value I'm asking about, and then it'll give me the corresponding y value on the line. So if I put in x equals 2 and hit enter, it gives me back the predicted y value. Now the y value that we actually got for a data point was 0.5. The line is predicting a slightly different answer, 0.0503, blah, blah, blah. Yes, ma'am? Sure, yeah, let's go back a little bit. Okay, so if we want to, let's just go back to here. So we've got the graph. Everybody okay with that?
Yeah.
We got rid of the scatter plot. Okay, so we got the graph. Now, how do we find, if we want to try to evaluate this linear function for a certain value of x, in other words, we're going to plug in an x value and it tells us the y value. Well, one thing we could do is just plug the x value into this equation, and that would work also. But instead, let's go ahead and use the line, being as it's right there for us. So we'll go second calc, second F4, so it's behind the trace, like second trace. And then it takes us here, okay? We want the first option, which is value. So if I hit enter, it's going to ask me what x value. I'll put in the x value. In this case, we'll put in 2. Hit enter. And it does a couple things. The most important thing is it gives me the ordered pair of that particular point on our line. X is 2, y is 0.05, the two places. Okay. It does show me on the graph, it puts the cursor on that particular point, but that's just for show. That doesn't really help us that much. This is what we want, are the actual numbers. Now I got a question for you. This is, what's better here? The actual data point. Here, pretend this data means something. Pretend we're measuring something up here. We're trying to find a mathematical model to predict, I don't know what it's predicting. Who knows? I mean, maybe it's predicting rainfall as a function of temperature. Who knows? I mean, we don't know for sure. But if it's actual data, the data told us, we collected some data that told us when x is 2, y is 0.5. The mathematical model that we just built is telling us something a little bit different. It's telling us that when x is 2, we should normally expect y to be 0.05 instead of 0.5. Okay? Which is better? Kelsey? Okay, then you must have different data in there then. It has to be that you have different, one of your data points must be different than mine slightly. Right, which means that when you put this data in, one of those probably got changed a little bit. If you go back and look at them, I guarantee. Because the calculators will all do the same regression. So it has to be that you entered something different than I did. And I might have made the mistake. Maybe it was me and not you when we were transcribing this, but somehow we're different. Is everybody else getting what I'm getting for this? Raise your hand if you got what I got. Okay, so probably if you got something different, probably you, I'm guessing that then you must have put in a data point incorrectly. And that's easy, that can happen. That really, you have to get very careful with this. It's so easy to just one little mistake on those numbers and it's going to change your answer. Okay, but back to my question. This is a really interesting question if you think about this. What's better? What's better, the actual data point when we took the data, or the value predicted by the model, even though it's different than the actual data we collected? What do you think? Let's vote. How many people say the model? How many people say the actual data point? Okay, it was leaning slightly towards the model. So the group as a whole was correct. It's the model. It's the model now because the data. Here's why. That might seem a little odd. How can the model be better than the data? Because statistically, data can fluctuate. Individual data points can fluctuate quite a bit. But if you take all the data as a whole, what it's going to do is it's going to average out the experimental error and the chance deviation from the average. Give you an example. What if we were to we had everybody flip a quarter 10 times? Would it be absolutely earth-shattering news if one of you got 8 heads and 2 tails? I mean, would we want to probably alert the press and have reporters come over here and interview you and all that stuff because you got 8 heads and 2 tails and 10 flips? Probably not. It's likely, I mean, at least one person probably would get something like that. You might even get 9 and 1. It's possible. I mean, that could happen. But if we flipped a coin 1,000,000 times as a group, let's say, and counted all those, do you suppose it's very likely that we're going to get 800,000 heads and 200,000 tails? I think it's possible. I mean, I guess you could say it's statistically possible, but we could do the math on that, and the odds would be so fantastically unlikely that it would be like if you had 1 trillion Earths and that represented 1 grain of sand on one of those Earths, it'd be like being able to pick that 1 grain of sand out of all. It just would be it's so unlikely as to say it's really impossible. I mean, it could happen, but it just never, ever, ever would because it's so unlikely. How come? Well, because when you get big numbers like that, all those little statistical swings just go away. And so really what that means is if we had 100,000 people flipping a coin 10 times, that adds up to 1,000,000, right? If we took all those people's data and we added it up, what we're going to find is it works out to be 50-50. There's going to be just about exactly 50% heads and just about exactly 50% tails. Yeah, you might have, maybe you have 35 more heads than tails, but 35 more heads than tails out of 1,000,000, that's not very much, right? That's pretty darn close to 50-50, right? You see why I bring that up? That's like this. When you take all these data points together and you build this model, it's a really good average. It's factoring out all the little swings in the data and giving us, most of the time, this is what should happen. Now, an individual data point can vary, but if you want to make your best guess, you're going to guess on the line. Okay? All right, last thing then. I'm going to put off the R-squared and the R. You don't need those for now. Don't worry about those. We'll get back to those later. I want to get you in the lab practicing this. What about this last one right here? Predict the value of y when x equals 12. Okay, same thing as before, right? We can just go second calc value. There's a shortcut for that, by the way. If I just hit trace and type in an x value, that's a shortcut. So if I hit trace 2, look what it does. It puts in x equals 2, and it gets me right back to that point with fewer keystrokes. So that is a little shortcut for you. But if I hit trace 12, it blows up. How come? Okay, it's out of the window. It's out of the window horizontally. It doesn't matter if it's out of the window vertically. That doesn't matter. But we have to have an x value that's in our window. So if we go back to the window here, notice what our x values are. The minimum x value is negative 2.7, and the maximum x value is 5.7. 12 is out of that range, isn't it? So what would we have to do then to be able to evaluate the function at x equals 12? Yeah, we got to put in an x max that's 12 or bigger. I'm just going to put in, so we can see it a little better so it's not right on the edge, I'm going to put in 15 about it. But it doesn't matter. I could have put in 20, it's fine. So I put in 15. If I hit graph, look what happens. All of a sudden now, because I've stretched the window out to the right so much, the graph just, it goes off the screen. That's okay, it doesn't matter. If I hit trace 12 now, even though the point doesn't show because it's way down here, it still gives me the y value. That's all I really care about. So the answer to number 3 is y equals negative 11.054 to 3 places. Okay? If I do want to see the graph, all I have to do is hit zoom 0, which is zoom fifth. If I hit zoom fifth, the calculator is going to resize the screen so I can see the whole line, which is kind of handy. But you don't have to do that. Now if I hit trace 12, I get the same answer, but I can actually see the point. But you don't need to. If you want to, there it is. Make sense? Okay, I got the computers already turned on. Let's go over to 332 and try a couple of these.